Okay, so silica is found in many construction materials today. So this presentation is intended to bring workers and employers an awareness regarding exposures to inhalable silica, which can be fatal, causing disease in the lungs. So today's webinar will include topics surrounding silica, such as what is silica, materials and forms of silica, tasks and job exposures, silicosis and its effects, jobs at risk, and safe exposure controls. Running two different PowerPoints here. Okay, the Encyclopedia Britannica states, silica, also called silicon dioxide, is a compound of the two most abundant elements in the Earth's crust, silicon and oxygen. The mass of the Earth's crust is 59% silica, the main constitute of more than 95% of the known rocks. Silica has three main crystalline varieties. So quartz, by far the most abundant, tridymite, and cristobalite. A little emergency overview. Silica is colorless crystals. It's odorless. It will not burn, and it's very toxic. Prolonged or repeated exposure causes damage to lungs. It's a cancer hazard, and it may cause cancer if inhaled. So some common silica-containing materials are concrete, block, cement, and mortar, masonry, tiles, brick, and refractory brick, granite, sand fill, dirt, and topsoil, asphalt containing rock or stone, abrasives used for sandblasting. These materials can be made into dust by cutting, grinding, blasting, sweeping, jackhammering, drilling, and crushing. Other sources of silica can be plastics, paints, fiberglass, marble, slate, soil, mortar, plasters, and shingles. Methods for containment and cleanup. Avoid dry sweeping. If necessary, use a dust suppressant such as water. Do not use compressed air for cleanup, and collect using shovels and scoops or approved HEPA vacuum and place in a suitable container for disposal. So if anybody's ever sanded drywall or swept a dirty floor without a mask, I know I have, you can imagine the exposure, the risk that you're getting to your lungs. So if you were working in the area pictured here, imagine breathing that dust day after day. What do you think that exposure is going to do to your lungs? And did you know that the Saskatchewan Employment Act and the Occupational Health and Safety Regulations identifies laws for silica processing and abrasive blasting, which applies to any place of employment or work site where a silica process is used. Part 24, Occupational Health and Safety Regulations, number 346, right through to 348. Some examples of jobs and tasks that could put you at risk of breathing silica are highway and bridge construction and repair, building construction, demolition, and repair, abrasive blasting, masonry work, concrete finishing, and drywall finishing. Crystalline silica is more likely to be present in the air when you're cutting, sawing, drilling, or crushing concrete, bricks, cement, ceramic tile, rocks, or stone. The processes that can put you at risk, many building demolition processes, power cutting of stone, facade renovations, all that fancy brick that's on the front of those houses, abrasive or hydroblasting of concrete, cleanup activities like dry sweeping or pressurized air blowing of concrete or sand dust, tunnel excavation or earth moving of soils with high silica content. Silica's many uses include refractory brick used in foundries, power plants, and cement, filter media for water filtration systems, sandblasting abrasives, building materials such as concrete, grout, and plaster, glass and fiberglass, components for electronics, fiber optics, lasers, and timekeeping devices. So how does silica dust hurt you? When crystalline silica particles are inhaled, they make their way deep into your lungs, which in turn begin to develop scar tissue, nodules around the particles. In general, the more you are exposed to silica, the greater you are at risk. Crystalline silica dust can cause a disabling, sometimes fatal disease called silicosis. The fine particles are deposited into the lungs, causing thickening and scarring of the lung tissue. The scar tissue restricts the lung's ability to extract oxygen from the air. The damage is permanent. Though it can take years for full symptoms to appear, silica exposure has been directly linked to lung cancers, chronic obstructive pulmonary diseases, kidney disease, and it can lead to arthritis and other health problems. Whoa, slow down. Okay, the warmth and beauty imparted from surface coverings using natural stones such as quartz, granite, and marble have long been considered a luxury item in new homes, as well as kitchen and bathroom restorations. Crystalline silica is a basic part of the earth's sand and soil and is found in many minerals, including natural stone, materials used in today's common constructions, materials in countertops in the kitchen and bathrooms. The table shown here is from the American Geological Institute. It describes the typical silica quartz content of common natural and engineered stone. So compared to the other stone surfaces, quartz is set apart in that it is not wholly organic. Quartz slabs are manufactured using 95% crushed quartz stone and 5% compound resins. The synthetic component makes it the easiest stone surface to maintain and increases color variety, durability, and stain resistant. Unfortunately, quartz countertops have over twice the amount of crystalline silica as granite and nearly 10 times the amount of silica found in marble. Workers in the natural stone cut industry, as well as those involved in finishing and installation of both natural and manufactured stone, are at risk of significant silica exposure. In both industries, production operators such as sawyers, inspectors, including quality control technicians, and staff who perform maintenance and housekeeping duties in manufacturing facilities also may be exposed to hazardous levels of airborne silica dust. Depending on the stone in question, countertops may contain over 90% silica. The highest silica levels are associated with manufactured countertops, where the pigments and adhesives comprise the remaining materials. Silica content is generally lower in natural stone products, calcium-based stones, including limestone and certain varieties of marble, calcite, dolomite, and onyx. My girlfriend's a geologist. I'm never going to hear the end of mispronouncing any of these words. So they contain little or no silica. In contrast, granite can contain up to 45% silica. So did you know that approximately 900,000 Canadians are occupationally exposed to silica on a regular basis? Among the most at risk are construction workers, heavy equipment operators, plasterers, and drywallers. Other construction tasks like drywalling, where workers who sand drywall joint compounds are often exposed to high concentrations of dust, and in some cases respirable silica. Drywall joint compounds are made from many ingredients: talc, calcite, mica, gypsum, and silica. Some of these have been associated with varying degrees of eyes, nose, throat, and respiratory tract irritations. Over time, breathing the dust from the drywall joint compounds may cause persistent throat and earway irritation, coughing, phlegm production, and breathing difficulties, similar to those of asthma. Smokers or workers with sinus or respiratory conditions are at a higher risk of health problems. When silica is present, workers are faced with an increased risk of silicosis and lung cancer. Several lightweight sanding systems are available to help control drywall work exposed to the sanding procedure. NIOSH study results suggest that construction workers' dust exposure might be reduced by simply by changing from hand sanding to pole sanding. This change is even more important when working overhead. The pole increases the space between the worker and the sanding surface, which in turn reduces the amount of dust close to the worker's nose and mouth. In addition to lower exposures, vacuum sanding can help the sander, subcontractor, general contractor, and building owner in other ways. The dramatic reduction in airborne dust exposure results in a much cleaner work area during and after sanding. For workers, the clean working environment is more comfortable. It's less irritating to the eyes, nose, and throat, is less likely to require respiratory protection. For the subcontractor, a comfortable worker is likely to be more productive and be absent less often and require fewer breaks for fresh air. The savings and reduced regulatory liability given by lowering respiratory protection will be passed from the subcontractor to the building owner. Other cost savings will result from a cleaner environment that reduces dirt, cleanup time, and repair or repainting of stained floors and carpets. So, as stated previously, one of the highest risks for workers repeatedly exposed to silica is silicosis, which is a non-reversible lung disease with symptoms that can range from a shortness of breath and chest pains to an eventual inability to breathe that could turn fatal. For people with a smoking habit or existing lung conditions such as asthma, exposure to silica can seriously compound debilitating lung and breathing problems. Silicosis is caused when crystalline silica particles are less than 10 microns in diameter are inhaled and deposited into the lungs. Respirable silica. Lung tissue reacts by developing lumps and scarring around the trapped silica particles. When the lumps and scar tissue grow too large, breathing becomes more difficult and death may result. It is a disabling, non-reversible, and often fatal lung disease caused by a long-term breathing of silica dust. It is also known to cause lung cancer and is considered carcinogenic to humans. Additionally, exposures to silica have been associated with other respiratory diseases like chronic obstructive pulmonary disease, including bronchitis and emphysema, tuberculosis, as well as kidney and immune system disease. There is no cure for silicosis and treatment options are limited. This disease is 100% preventable if measures are taken to reduce exposures. Some of the signs of silicosis are shortness of breath caused by the swelling in the lungs and the chest lymph nodes, severe cough, weakness, fatigue, loss of appetite, and respiratory failure. A worker may develop any 3 types of silicosis depending on concentrations of the silica dust and the duration of the exposures. So chronic silicosis develops after 10 or more years of exposure to crystalline silica at relatively low concentrations. Accelerated silicosis develops 5 to 10 years after initial exposure to crystalline silica at high concentrations. And acute silicosis develops within a few weeks or 4 to 5 years after exposures to very high concentrations of crystalline silica. So provincial and federal authorities have established occupational exposure limits and guidelines to help manage the risks posed by airborne silica. But research has shown that long-term contact with even small quantities of the mineral may have serious impact on your breathing and overall health over time. So if you're unsure of the different products and processes being used around your site, you can reduce the potential risks of exposure by wearing the appropriate protective gear, PPE, For drywall compounds, you should always refer to the SDS safety data sheets for the recommended exposure control methods and other pertinent information. So we have a video here. As you know, people learn differently. There's multiple styles of learning, verbal, kinetic, hands-on, auditory, and visual. So for all you visual learners, this short 2-minute video from WorkSafe BC is a really great, video. Let me just see if I can make it work though. So. We'll just access it differently here for you. I apologize, our internets are a little bit slow around the office today.
Silica. It's one of the most common substances on Earth. It can be found in materials like sand, and rock, and building products like concrete and brick. When a worker
Sandy, I'm seeing your PowerPoint right now, but I am not being able to see the video.
Okay, thank you, Mike.
Yep.
Let's just go back into.
Just while Sunday's getting that set up right now, I think to elaborate just a little bit more on respiratory, using your PPE and stuff, just to keep in mind that if we are using respiratory devices, that we should have training for fit care and use to this equipment as well. So just keeping that in mind, if you are putting a mask on for any reasons, with N95 and greater, there should be some sort of fit testing as well as training on the fit care and use for that respirator as well. So I just thought I'd throw that in there for you, Sunday. If I don't know if you're covering it in your presentation, sorry if you are, but
Great. No,
yeah,
that's great.
Yeah, just to touch on that.
Can you see the screen now?
We sure can.
Okay, let's try that.
That's working. Yep.
Perfect.
Silica. It's one of the most common substances on Earth. It can be found in materials like sand and rock, and building products like concrete and brick. When a worker cuts, grinds, or drills materials that contain silica, dangerous crystalline silica dust is released into the air. As the worker breathes, silica crystals flow into his mouth and nose and down the air passages deep into the lungs. The tiny crystals enter the small, fragile air sacs where oxygen is absorbed into the blood. Immune system cells, called macrophages, engulf and try to dissolve the crystals, but they are unable to. Over time, more and more crystals build up inside the macrophage cells. Macrophages carry the silica into the walls of the lung, where they die. Scar tissue forms around the dead cells and spreads as more cells die. This damage can continue even after the exposure to silica stops. Eventually, so much scar tissue forms that the lungs can no longer function. For information on how to protect yourself from silica exposure, visit bc.com.
Sandy,
Yes.
would you be able to? I think I didn't want to cut off the video. It was really choppy, and I think the sound quality was really low. You want to? I think the visual was still really good to see. You want to just go through a little bit of what they were talking about?
Well, it kind of goes through it. That was more for the visual learners. We've kind of touched points in throughout the presentation. It just goes a little bit more into the lungs, and it gives a real visual kind of identity or process for anybody that's interested. We can post the link at the end here if anybody wants to review the video, and hopefully it streams a little bit better for you. See if I can post it, or here we go. There is a little bit more of the presentation left, Mike, by the way, sorry. What are we seeing here?
I can see your PowerPoint right now.
Okay, perfect. We're getting close. I should say thank you to Justin for assembling the majority of these slides. Justin Brooks, another advisor. Okay, back on track here. So, to most effectively reduce silica exposure, employees should understand what crystalline silica is, who is at risk of exposure, and the dangers of high levels of exposure. Preventing exposure to silica is the best way to protect our health. Always refer to the hierarchy of control. Hi.
Do you want to start the presentation? Sorry.
Okay, sorry, it's not working, the screen share?
No, my computer's super slow, so I think it's just a bad network all in all. There we go, perfect.
Speaking of slow, okay. Let's go back a few slides.
There we go. Good job.
Not that there's much. Okay, so engineering controls. Always refer to the hierarchy of controls and consider engineering controls first. There are a few different ways of keeping dust levels down on your construction site, which in turn will keep silica particles from becoming airborne. Engineering controls are mechanical processes used to eliminate exposure to dust. Engineering controls remove the dust from the air or provide a barrier between the worker and the dust. Examples of engineering controls used to prevent exposure to crystalline silica include wet processes such as wet abrasive blasting or wet cutting, the installation of local ventilation hoods, installing dust collection systems onto machines or equipment, dust control additives, enclosures around the work processes, automated processes, example robotics, and use of alternative equipment, use of a HEPA vacuum instead of compressed air, or dry sweeping to remove debris from cracks in, say, road repair. Employers and employees should consider to substitute, if at all possible, with a safer material, changing work practices to reduce exposures, administrative controls, install signage warning workers of the hazards and informing them about the required protective equipment needed in the areas where they may be exposed to silica. Use work practices to reduce exposure is often less expensive than other control measures. However, workers must be trained to use practices properly and have their work activities monitored by the employer. Control dust exposure with work practices, again, such as water sprays, ventilation cabinets. Many workers will opt for methods like the wet cutting and vacuum dust collection systems, intense ventilation, or hosing down of work sites to keep the silica dust from forming. Use protective equipment or other protective measures. Ensure respirator is suitable for the job, certified, and that the worker has been fit tested by a certified respirator fit tester. So what you were discussing previously there, Curtis, make sure that your workers know how to use their PPE appropriately and are trained in it. Employers can help protect themselves by, employees can help protect themselves. So by changing out of your work clothes before going home, participate in the training, exposure monitoring, health screening, and surveillance programs to monitor any adverse health effects caused by exposures. Be aware of the work practices and tasks that create exposures. Be aware of the health hazards and that smoking adds to lung damage caused by silica exposures. Hygiene. Workers must not eat, drink, or use tobacco products in areas contaminated by crystalline silica. The hands and face should be washed outside of the dusty area before you or smoking. Educate workers to understand the hazards associated with crystalline silica. Workers must participate in training and monitoring programs. Occupational Health and Safety Regulation 350 states cleanup of work sites. An employer or contractor shall ensure that all work sites and work-related areas where dust from a silica process may affect the health or safety of a worker are regularly cleaned using a vacuum that has a HEPA filter on the exhaust, or where vacuum is not practicable by using wet methods. Whoa. Just going right to the end. Occupational Health and Safety Regulation 348, warning of workers. An employer shall warn all workers who, in the course of employment, are likely to be engaged in a silica process or are likely to be exposed to silica dust of the dangers to health from the inhalation of dust containing silica. So planning is essential to reduce exposures and protect workers. Protect workers from overexposure to silica dust by developing your written exposure control plan that meets or exceeds the requirements laid out in the Occupational Health and Safety Regulations. A written exposure plan should contain at least the minimum following elements. So you want to identify what silica is, purpose of the exposure control plan, responsibilities, risk identification, assessment, and control, a description of the tasks in the workplace that involve exposure to respirable crystalline silica, education and training, safe work practices, a description of engineering controls, work practices, and respiratory protection used to limit employee exposure to respiratory silica for each task. A description of the housekeeping measures used to limit employee exposure to crystalline silica. A description of the procedures used to restrict access to work areas when necessary to minimize the number of employees exposed to the respirable crystalline silica and their level of exposure, including exposures generated by other employees. Health monitoring program and documentation. Employers are also required to review and evaluate the effectiveness of the written exposure control plan, at least annually, to update it as necessary and designate a competent person to implement the plan. So get the correct PPE. Once you have a sense of your exposure level, you'll want to take a look at a full range of respiratory protection products to find the right product for your level of risk. Whether it be a lightweight disposable respirator, a half-face respirator, or full-face protection. If it is not practicable or feasible to substitute, use engineering controls or change your work practices to control the exposure. Personal protective equipment may be needed and is always your last line of defense. Many types of respirators are available, and it is important to select the correct ones for the work being done. In addition to respiratory protection, workers need to be provided with appropriate protective clothing at the work site. This is done to make sure that the street clothes do not be, they're contaminated with silica. Your eyes should be protected to prevent the silica particles from entering them, causing irritation or damage. Work practices can be implemented to reduce potential exposures. Although the use of personal protective equipment may initially seem to be less costly, workers need to be trained in how to use it. Employers need to monitor use and ensure that the PPE is maintained properly. Issues such as heat stress, restricted vision, and allergic reactions to the equipment material need to be evaluated when personal protective is being selected. Stay informed of the rules and regulations around managing silica exposure. It's it's important to stay updated with legal limits, testing methods, and the latest data on how you can minimize the risk. Know your limits. OSHA has established permissible exposure limits for silica, in which the maximum allowable limit a worker is allowed to be exposed to in an 8-hour shift is identified. Did you know that the SCSA has an app for that? You can download the SCSA app for free from your app store. You can also download one of our toolbox talks on silica from our app or from our homepage. So I guess that wraps it all up for you guys. Thank you for taking the time to view the presentation. For any questions, please feel free to contact us, and we're always here to help you out in whichever way we can